Hi, this is Niki Sensei. So today we'll try to study math and let's try to convert units of angles. So the most common units of angles that you encounter in math or in science are degrees and radians. So usually you see degrees with this unit and radians as rad. So let's start conversion round. So whenever I try to convert, I always think of this conversion factor. And it's 180 degrees equals pi radians. Okay. And then whenever I try to convert units, I always use the method called dimensional analysis. So if you've just started learning math, maybe you may not have encountered dimensional analysis yet. I first encountered this when I was in third year high school, so when I was taking up chemistry, because there's a lot of conversion happening in chemistry. And in dimensional analysis, it's simply using this conversion factor as a multiplication factor so that I can cancel out units later on, and then what's left would be the unit that I'm looking for. For example, if I'm converting, let's say I have 10 centimeters and I want that to be converted to meters, I use dimensional analysis. By using this conversion factor, I know that 100 centimeters equals 1 meter, right? So I start first by writing the given number, so it's 10 centimeters, and then I multiply that with the conversion factor. So you have centimeters here, right? So your centimeters is in your numerator. So when I write the conversion factor, I use this conversion factor of 100 centimeters equals 1 meter, and then I write the number which has the same unit as this in the numerator to the denominator. So I'm going to write 100 cm in the denominator because later on you'll see that the centimeter here in the numerator will be cancelled out with the centimeters in the denominator. And then 100 cm is equal to 1 meter. So that's my conversion factor. So let's proceed with the operation. So you have 10 cm times 1 meter over 100 cm. But since you have centimeters in your numerator, so you cancel out the units here because they're the same. So I'm now left with 10 times 1 meter over 100. Or to simplify this, I would have 10 meters over 100. But how are the numbers simplified? Right? So this 10 meter over 100 is just equal to this 10 over 100 with the unit of meters. So, but what is 10 over 100? I can also take note that 100 is simply 10 times 10, correct? So if I rewrite that, I would have 10 in the numerator from here, and then 100 is simply 10 times 10. And then I write the unit here. But, so now we have 10 over 10 times 10 meters. So I'm seeing similar numbers both in the numerator and denominator. So I can cancel them out. So I would be left with 10 over 10, any number divided by itself is just 1. So I'm going to write 1 in the numerator, and then what's left in the denominator is 10. So my answer here would be 1/10 meter. So we know, we go back to the first line here. So now we know that 10 centimeters equals 1/10 meter. So now let's go back to conversion of degrees to radians. So let's go with degrees to radians. Let's say, for instance, I ask you to convert 270 degrees to radians, right? Let's write down our conversion factor, which is equal to 180 degrees equals pi radians. Okay? So let's start. So we always start with a given number. The given number is 200. What's happening? The given number is, oh, what's happening? 270 degrees What? I'm encountering technical problems. I must have pressed something. Let's see. No. Hold up. Okay. Okay. Okay, so let's start with 270 degrees and convert that to pi radians. Okay, so 270 degrees times, our conversion factor is this, 180 degrees equals pi radian. Okay, so the degree is in the numerator, so I'm gonna write 180 degrees in the denominator and copy pi radians. So this is just equal to 270 degrees times pi radian all over 180 degrees. Simplify. So the degree here can be cancelled because I can see it both in the numerator and denominator. So I would have 270 times pi radian all over 180. Let's try to simplify 270 divided by 180. So I know that 270 has a factor of 10. So 270 is just 27 times 10, and then 180 is just 18 times 10. So I factored out 10 so that I can cancel them out. Okay? So since they are both present in the numerator and the denominator, I can simply cancel out 10 over 10. Because 10 over 10, anything that you divide by itself is just 1. So I'm now left with 27 over 18. So do you think there are other factors that are common both to the numerator and denominator? So let's try. I'm gonna write down factors of 27 over here. So 27, the factors of 27 could be, let's start, 1 and 27, 2, 3, and 9, 4, 5, 6, 7, 8, 9, and 3. So I think these are all the factors of 27. And then 18. So the factors of 18 are, I'm starting from 1. If you notice, I'm starting from 1 to just 1 to 10 is okay, because these are like the prime numbers. So I'm trying to get the factors of the prime factors of each of the components of our fraction. So the prime factors of 18 would be 1 and 18. What else? 2 and 9, 3 and 6. How about 4? No, it's not divisible by 4. 5, 6 and 3, 7, 8, 9 and 2. Okay, so we've listed down all the factors of 27 and 18. So now let's look at the common factors of these two, except for 1, because 1 is the simplest number. If we try to write down 27 and 18 in terms of their factors 1, we'll still come up with the same number. Correct? Because even if we try to cancel out 1, we will come up with still 27 and 18. Okay, so other than 1, let's look at other factors. So I'm seeing a common factor here. So it's 3, 3, and so I'm seeing 3 here. So I'll try to rewrite 27 and 18 in terms of their common factors. So 27 is simply 3 times 9, and 18 is simply, 3 and 6. So if we follow this, we can cancel out 3 here, and we're left with 9 over 6. But if you notice, 9 and 6 have common factors as well. Okay? So aside from 1, let's list out the common factors of 9 and 6. So let's start with 9. So we have 9, 1 and 9, 3 and 3. That's all. For 6, we have 1 and 6 and 2 and 3. So note that we still have common factor of 9 and 6, that is 3. So we can write down the fraction 9 over 6 as 3 times 3 divided by 2 and 3. So the common factor is 3, so we can cancel out 3 in both the numerator and denominator, and the final answer, the simplified form, would be 3 halves. So note that we started from 270 divided by 180, and that is just equivalent to 9 over 6. So I'm going to write it here. So I know that 270 divided by 180 is just 9 over 6, and then I copy Pi Radians. Oh, wait up. Why is this not? It's just 3 halves. Sorry, it's 3 halves. 3 halves. So it's 3 halves. So we come back here to our conversion, and we know that 370 degrees is just equal to 3 halves pi radian. So this is our final answer. So let's now go to radians to degrees. Radians to degrees. Rad to degrees. Okay. Say for instance, I ask you to convert let's say 3 pi over 2 radians to degrees. Okay, let's start. So remember our conversion factor. (180 degrees) equals pi radians. So let's now start. So I'm writing 3 halves pi radian times. So I'm going to copy this into the denominator because I have radian as my numerator, pi radian, and copy the remaining factor here, 180 degrees. Alright, take note also, 3/2 pi radians is just equal to 3 pi radian over 2. So don't get confused, okay? So whatever the label here, you can just attach it to the numerator. So they're the same. So let's go now to our conversion. So I have 3 pi radian. So I'm going to copy all the factors in the numerator. So 3 pi radian times 180 degrees divided by 2, because 2 is in the denominator here, and pi radian from here. Okay? So I'm seeing common units, common terms. So I'm going to cancel out the common term, which is pi radian, which are both present in the numerator and denominator. So I'm now left with 3 times 180 degrees divided by 2. Okay, let's try to analyze if... So in solving this problem, you can easily just multiply 3 with 180 degrees and then divide it by 2. So that's one of the methods of getting the answer for this. So it's just 3 times 180, which is just 540 degrees. 540 degrees divided by 2. But what is 540 degrees divided by 2? So 5 divided by 2 is 2. 2 times 2, 4. 5 minus 4, 1. 14 divided by 2 is 7. 7 times 2, 14, 0. So 540 divided by 2 is just 270 degrees. Or I can also do this. So I know that, let's come back here to this line. 3 times 180 degrees divided by 2. Okay, so between 3 and 180 degrees, which do you think has a factor of 2? So I can list down the factors of 3 and 180 degrees. So the factors of 3 are just 1 and 3. As for 180, it could be 1 and 180, but we're actually looking for the counterpart if we divide it by 2. It could also be 2 times 90. So let's try to simplify. So 3 and 180 expressed as a factor of 2 is just 2 times 90 divided by 2. And I can simply look at the equation and I know that I can just cancel out 2 in both numerator and denominator. So I'm left with 3 times 90, which is just 270 degrees. Okay, so going back to the problem, I can write that 3 3/2 pi radian is equal to 270 degrees. Alright? It's easy. So you can just simply practice more on conversion of units, conversion of degrees to radians and radians to degrees using our conversion factor of 180 degrees equals pi radians. Do you have more math questions? So if you have more math questions, feel free to type down in the comment section below so I can make videos about your math problems. Bye!